In today's lesson, we're going to solve two-step equations. Notice our I can statement is I can solve two-step equations. On a note, just to kind of get us started, remember to isolate the variable and also remember to use inverse or opposite operations to solve. Our first problem is 7 is equal to 2n plus 3. So we want to isolate the n or get it by itself. Ultimately, what we're trying to find out is 7 is equal to 2 times what number plus 3. So we always want the left side of our equation to equal the right side of our equation. So to get the n by itself on the right, we have to get rid of the positive 3. In other words, our attention is going to the right side of the equation because that's where we see the variable. So whatever else is on the same side of the equation as the variable has got to go away. So we look at this and we say that's a positive 3. So to get rid of a positive 3, we're going to subtract 3. Whatever you do on the right, you also have to do on the left. So we have 7 minus 3 or 4. Bring down the equal sign. Make sure your equal signs are lined up. All that's left on the right then is 2n because our mission is accomplished. We have made a positive 3 and a negative 3 that is equal to 0, so that gives us a 2n. If at this step you look and you say, oh, you know what, I forgot, I added 3 instead, you definitely don't want a positive 3 plus a positive 3, which is a positive 6. Remember, once again, our goal is to get the variable by itself. At this point, we see that we have 4 is equal to 2n. We know that that means 4 is equal to 2 times some number. The opposite of times or multiplication is division, so we always divide through by the coefficient. 4 divided by 2 is 2 is equal to 2 divided by 2 is 1. So that gives us 1n on the right, which is exactly what we were going for. So all that's left on the left is n is equal to 2. I prefer, it feels a little unfinished when I end up with 2 is equal to n, so I prefer to turn my variable and have that on the left, and that's what you should do as well. So then we have to kind of check this and say, okay, did we do this correctly? 7 is equal to 2. Now we said that the value of n is 2, so 2 times 2 plus 3. And then order of operations kicks in. We know that it's more important to multiply than it is to add, and as you can see, that does check. If you're asking yourself right now, well, do I have to grade or check every single problem? Well, that's entirely up to you. I wouldn't say to do that on every problem, but especially if you're struggling or just not quite sure, then I would suggest checking your work. Now let's look at number 2. 70 is equal to 30 plus 1/4 c. So we're trying to find the value of c. In other words, 1/4 of some number plus 30 is equal to 70. So the same rule applies. We want to isolate the c or get it by itself. To get the 1/4 c by itself, we're going to have to get rid of a positive 30. If you're wondering, how do we know that's a positive 30? Well, if there isn't a sign in front of it, then that is a positive 30. So the only way to get rid of a 30 is to subtract 30, and we're going to do that on both sides. Down. Make sure you bring down your equal signs and make sure that you have subtracted 30 from 70. Now, I want you just to kind of sit back and listen for just a minute. We have 40 is equal to 1/4 c. So if I'm going to do the opposite of multiplication, because it's 1/4 times some number is equal to 40, then I would divide through by the coefficient. And this is where it's going to look a little strange. So if we go back and look at number 1, we know that when we got to the step right here, 2n divided by 2, because we want to divide by the coefficient, we just divided through by the whole number. Well, number 2 is a little bit different because instead of a whole number or integer coefficient, we have a fraction coefficient. So I want you to kind of look at that, and I know you are agreeing, yeah, fraction divided by a fraction, that just looks weird. Let's say instead I was doing this. Let's say on an assignment, I was doing 40 divided by 1/4, and I was doing that pencil paper work. We know that the directions are to leave the first number alone, change division to multiplication, and change the second fraction only to the reciprocal. And the reciprocal is the number that you multiply by the given number to get a product of one whole. So what we would end up having then is 40 times 4, which is 160. Well, exactly the same thing applies here. I've just told you to kind of put that on hold, and you're not going to show divided through by a fraction. That is mathematically incorrect because we can't figure that pencil and paper, but I wanted you to understand that the rule does not change just because you have a fraction coefficient. So this is what it's going to look like instead. Please use big parentheses to represent your multiplication. It's not a big deal now when you're only multiplying through by 1, but when we're going to use a distributive property in a few lessons from now, it's going to be really important. So please just trust me, and I want you to get in the habit of using big parentheses instead of multiplication symbols. So on the left, we end up with 160. And on the right, we have the c. And then as I mentioned on example number 1, we're just going to flip that around so that our variable ends up on the left. And it should make sense that 70 is equal to 30 plus 1/4 of 160. So if you were checking it, it would look like this. Moving on to our next example. A divided by 5 plus 15 is equal to 30. So really we're saying some number divided by 5 plus 15 is equal to 30. I want you to understand that a over 5 is exactly the same thing as 1/5 a. So sometimes you'll see it with the variable written in the numerator, and sometimes you'll see it with the fraction out in front of it, but once again, it's exactly the same thing. If you're thinking, well, how is that the same thing? Well, if I take any number and multiply it by another value, then I'm talking 1/5 times a, and then as you can see, that equals a over 5. So once again, just remember that those are exactly the same problem. It's just written a little differently. So to get a over 5 by itself, we're going to subtract 15 on both sides. All that's left on the left is a over 5, and on the right we have 15. Notice again, my equal signs are lined up. So I know that in front of that a is really, it's like 1/5, and so we don't show divided by 1/5. I showed you that on the last example. It looks a little strange. So instead of showing dividing by 1/5, the reciprocal of 1 over 5 is 5 over 1, and I prefer just a 5. That's all that's necessary. All that's left on the left is a, and we have 15 times 5, or 75. Does it make sense? 75 divided by 5 plus 15 is 30? Absolutely, because 75 divided by 5 is 15. 15 plus 15 is 30, so that does check. In our last example, the only thing that makes this problem a two-step equation is that we have a negative d. If that was a positive d, this would just be a one-step. But that negative d is going to make us divide through by a coefficient on the last step. So even though it's a decimal, we're going to treat it exactly like we would if we were dealing with integers. We want to isolate the d or get it by itself. So we're going to subtract 4.3 on both sides. And you'll notice that I stuck in the -1 right in front of the D just so that I remember what number I'm actually dividing through by. So our coefficient is -1, so we'll divide by -1 on both sides of the equation. And just like in previous examples, you'll notice that my last step is that variable on the left side. So really it's just saying a negative, -6.4 plus 4.3, and that does give us a 10.7. So sometimes just checking it is just kind of looking and seeing if your answer makes sense. You don't necessarily have to write it down unless you feel the need. And our last example today is going to look a little different than examples that you've seen in the past. In fact, you may not have ever seen anything like this before. But I want you to remember what I just talked about a few minutes ago, and that is whatever is in front of the variable is always going to be a number 1. So usually we talk about a coefficient being just in front of a variable. That's sort of what we're used to. So let's just say that would be a -1/4 a. Well, the same thing applies here for this fraction. I can put a 1 in front of this fraction and I haven't changed the value at all. So then we're dealing with exactly what we talked about before, which is to get rid of the coefficient, we divide by the coefficient, but I'm not going to show dividing through by a -1/4. So some of you can kind of see where this is going already. And instead of showing dividing by -1/4, we multiply by what? Oh yes, that's right, the reciprocal. So we're going to multiply through by -4 on both sides of the equation. Notice my big parentheses. And then if you know that step, and if some of you are saying, well, Miss McDaniel, aren't you just multiplying by the denominator? That is true, but it's not because it's the denominator. It's because it's the reciprocal. And when you end up with a numerator other than 1, then you're going to know exactly what to do. So that's why I teach you that way up front. So we're going to when I multiply by -4, that's multiplying by a -4, dividing by a -4. So those cancel. We like that part. All that's left on the left is a minus 10 is equal to -8. And this is a one step. To isolate a, we're going to add 10 or use the opposite operation on both sides of the equation. So we end up with a is equal to +2. And let's see if that makes sense. 2 minus 10 divided by -4 is equal to 2. Well, that would be -8 over -4. We know that a negative divided by a negative is a positive. So it looks like we've done a really good job. So that will do it for solving two-step equations.